Okay, Algebra 2 kids. This is section 8.5. I've kind of done with it what I did with 8.4, the ellipses. 8.5 is hyperbolas. This is another conic section. And again, I added some more notes. These are some snippets from a snipping tool that I cut out of the textbook pages and added to your study guide notes here for 8.5 for hyperbolas. If you remember, an ellipse is the set of all points in a plane such that the sum of the distances between the points and the two foci is constant. Okay, now let me just kind of quickly draw that. If you've got an ellipse, remember, okay, and you've got your two foci here, these two distances are always going to be constant, okay? So if I call this A and this B, then your A plus B is constant, okay? That's an ellipse. Now, what we're doing today is hyperbola. Hyperbola, notice, is the set of all points such that the difference of the distances between P, which P is a point on the hyperbola, and two fixed points, foci, is constant. So this, I want to point out, is a plus. This over here is a minus. Okay, that's the difference. Okay, so hyperbolas, they kind of look like two parabolas. They're not really parabolas, but they kind of look that way. So again, ellipses, the distance, okay, from the foci to any point, the sum is constant. On hyperbolas, from a point to any to the foci, the difference between those distances is constant. So once again, I'm going to try this. I did this on the ellipse. This is kind of a GIF. I don't really like this one as well as I liked the ellipse one, but let's see if this maybe helps a little. So again, we're talking about conic sections here. You can tell, see the red dot that's moving are all the points on the parabola. They're kind of using circles there to show you the different radiuses or radii of circles, but the difference between those distances is constant in a hyperbola. In an ellipse, the sum of those two distances is constant. So that's what changes between hyperbola and ellipse. Okay. Now, now on an ellipse, if you remember, actually let me label this one so you know this was an ellipse that we were talking about, just kind of as a reminder. We had a major axis and we had a minor axis on an ellipse. A major axis was your longer one. Okay. Your minor axis was your shorter one. Your major axis, you knew whether it was horizontal or vertical, depending on whether your bigger number was under the x squared or the y squared. On a hyperbola, it's a little different. It says, I'm reading that kind of third paragraph there, the line through the foci intersects the hyperbola at the two vertices, okay? Kind of like, again, the vertex of a parabola, kind of the same thing. The transverse axis joins the vertices. We no longer have a major and a minor axis. We only have one axis, and that goes from one vertex to the other. So let me kind of draw from like here to here. From one vertex to the other would be your transverse axis. Okay, its midpoint is the hyperbola center. So smack dab in the middle. So these are the two vertices of the hyperbolas, okay? And smack dab in the middle would be your center. Okay, now for us today, the center is always going to be at the origin. Okay, and I keep calling them like two parabolas. We actually call them branches. It says a hyperbola has two branches and has two asymptotes that contain the diagonals. Remember what an asymptote is? An asymptote is a line that your graph gets really, really close to but never crosses, okay, never touches. So in order to graph these today, again, they're different than parabolas, even though they kind of look like it. We actually draw the asymptotes, and then that kind of tells us how fat or skinny our two branches of the hyperbolas are. Okay, so let's kind of dive in here. Okay, so again, cut out of the textbook, but I really like the pictures. Big thing I want to point out difference. When we had an ellipse, our basic formula was like x squared over a squared plus y squared over b squared equals 1. Big difference with a hyperbola. Notice the middle is a minus now. Okay, we still have the 1 as the constant on the right side of the equation, but now we have a minus instead of a plus. That's the big difference between hyperbola and ellipse. Okay, ellipse has plus, hyperbola has minus. Also, on hyperbola, if you remember, again, let me backtrack to ellipse. If you remember on ellipse, whichever number was bigger, the a squared or the b squared, that determined your major axis, whether it was horizontal or vertical. Okay. On a hyperbola, excuse me, on a hyperbola, it's whichever one is in the front is going to give you your vertices for your transverse axis. Okay, whichever one is in front. So notice here on these formulas, both of these have an a squared. Okay, what's different, however, is that this one starts with an x squared, this one starts with a y squared. That's the difference. The ones that start with an x squared have a horizontal transverse axis. The ones that start with a y squared have a vertical transverse axis. Okay, so that's the difference. You don't really have to figure out, you know, which one's a squared based on whether it's bigger or not. A squared is always in the front, okay? But it depends on which variable it's under, whether it's under the x squared or under the y squared, okay? Which one's in front. That's going to give you your transverse axis. So in the case of the one here on the left, where we start with x squared over a squared, again, these are our a's. These are our vertices, okay? Right there. Those are our vertices. Now our focus, if you remember on an ellipse, your foci were inside the ellipse and it was all enclosed. Well, now your hyperbolas have two branches that open up opposite each other, you know, either left and right or up and down. And your focus is inside the bowl, kind of like the focus was in a parabola. Okay, so your focus here and here. Now, again, focus is the same thing as like an ellipse. We use a C, but we have a different formula now, and we're going to get to that down below, but I want to go ahead and write it. If you remember, the formula for C for an ellipse was C squared equals A squared minus B squared. On a hyperbola, C squared equals A squared plus B squared. And I kind of remember these just because I think opposite. Hyperbolas have a minus in the middle of the standard equation. So then to find C, there's a plus between the A squared and B squared. Ellipses have a plus in the middle of the standard equation. And to find your C squared, it's A squared minus B squared. Okay, so it's kind of opposite signs, if you will. That's kind of how I try to remember it. So that's how we find our C, okay, for a hyperbola, is it's A squared plus B squared. Now, this again, I don't know if you can see me trace the red over the red. This right here is your transverse axis. Again, it's horizontal because this started with X, okay? So your x-axis is the transverse axis. Okay, can't hardly read my writing there. Now, the B, the only thing really that B is used for, you can see those dashed lines. Your B gives, notice this is B, okay? This is negative B. This kind of gives us, notice these dashed, gives us a box. Okay, I'm big on drawing the box because I'm a visual person. but that box is where we get our asymptotes. Our asymptotes are the diagonals of that box or that rectangle. Remember, a diagonal goes from one corner to the opposite corner. So these right here, I'll just draw straight lines for the sake of time. These are our asymptotes. That's where the B comes in, okay, is getting our asymptotes. The asymptotes are the diagonals of the box formed by the width A and height B, okay? So in this case, your asymptote, I misspelled that. Let me try that again. Your asymptote on this one would be y equals, actually you're going to have 2, plus or minus b over a times x. Again, remember, your slope of a line is rise over run. So your b is on your y-axis, your a is on your x-axis. So over here, your asymptote on this right side is y equals plus or minus. This case, okay, your a, in this one with a vertical transverse axis, your a is running your y-axis. So this is a over b x, okay? Because again, they're all going through the origin of 0, so we don't have to worry about having a y-intercept. So those are your asymptotes, and that's how we know how fat or skinny the two branches of the hyperbola are. We have to follow the asymptote. Okay, so scrolling down here some more. This is kind of like, don't know why I'm getting these trending things from Reddit. Here's some more formula type things. Okay, so the equation, if we start off with x squared minus y squared, the transverse axis is horizontal. Okay, your asymptotes are going to be b over a because your b is your y, okay, in this case. So remember, slope rise over run. And then your vertices are plus or minus a comma 0. Okay, now let me also add to this, like I did on the ellipse one, your foci. Okay, your foci on this are going to be plus or minus c comma 0. Okay, now the one below, when you start with y squared, of course, your transverse axis is going to be vertical. Okay, so your a is going to be on your y-axis. So that's why your asymptote is a over b now instead of b over a, because a is on the y-axis. And then, of course, your foci for this one, since your transverse axis, I kind of in my mind think of transverse as your major axis, if you will, but your transverse axis is on the y-axis. So then your foci are on the y-axis as well. So that's going to be 0 plus or minus c. And again, I want to point out the formula for c. C squared equals a squared plus b squared, just the opposite of the ellipse. It was a squared minus b squared. Okay, so again, reminder, on a hyperbola, this is minus in the middle. Okay, and this down here is plus. Okay, now let's get to the front page of our study guide. I don't know why my board has this bad delay today. It's kind of bugging me. Okay, so hyperbola is the set of all points P in a plane such that the difference of the distances between P and two fixed points, called the foci, is constant. Then they talk about the vertices, and the transverse axis joins the vertices. Okay, and its midpoint is the hyperbola's center. For us today, the center is just going to be 0, 0. Now, look at this example 1. It says, graph this, identify the vertices, foci, and asymptotes of the hyperbola. Right off the bat, because this starts with x squared in the front, I know that this is going to be horizontal on my transverse axis, or x-axis is going to be my transverse axis. Okay, it's going to be horizontal because x squared is in the front. So again, notice what they did here. They divided the entire equation by 36. So then this is what the equation ends up as. Okay, well then this means that a is 3, right? Because a squared is 9. And b is 2 because b squared is 4. Okay, so again, vertices are at plus or minus 3, 0. Find the foci. Again, here is your formula for foci. Okay, so 9 plus 4 is 13, so the square root of 13 is root 13. Your foci are always on your transverse axis. Okay, so again, there's your foci. Okay, now asymptotes. Remember, asymptotes deal with slope of lines. It is always rise over run, so it's y over x. So it's going to be 2 over 3. I don't personally like to think, actually, let me do that in purple. I don't personally like to think of the formula to try to remember whether it's a over b or b over a. In my mind, I think rise over run. Rise has to be your y. Run has to be your x. So I think of it in terms of y over x. Okay, so I look up here at my original equation, and my 4 is under my y, my 9 is under my x. So take the square root of each of those, has to be the 2 over the 3. Okay, that's how I think of it. I don't like to memorize formulas. I like to think through it. That way it's less crap for me to memorize. Step 3 is drawing. Okay, so again, we've got our vertices here. So plus or minus 3, 0. Okay, root 13 is just a skosh bigger than that. So these are my foci. Okay, and then remember your b was 2. So we go up 2 and make our box with up 2 over 3. So these asymptotes have the slope of 2/3 and negative 2/3. Okay? And then, of course, once you have your vertex, you just draw your branch of the hyperbola hugging the asymptote line. That's why the asymptotes are so important. Okay? All right. Now, here's some more equations. Once again, like I did on the ellipse one, I am going to graph these on another page. I added some little graphs over there. So let's redo these next page. Okay, first problem. This was number 1. We have y squared over 4 minus x squared over 9 equals 1. Okay, now, first thing that jumps out at me, my transverse axis is going to be vertical. Okay, transverse axis is going to be vertical because my y squared started it. Okay. Okay, now, this then is my a squared, so this means a equals 2, right? This is my b squared, so that means b equals 3. So my vertices are always on my transverse axis, which in this case is going to be vertical because the y squared started it. So my vertices are going to be 0, comma, plus or minus 2. That's the first thing. Now, I don't have covertices like I did with ellipses. Okay, so first let me graph my vertices, up to, down to. Okay, now I am going to graph my B just really little here, because this is what's going to give me my box. Okay, I should probably use my line tool and get a nice pretty one, but that's going to give me my box. What do I need my box for? To draw the asymptotes, which are the diagonals of the box. Okay, so I know that my asymptotes, I don't know how straight my lines are. They're not, that second one wasn't very straight, was it? Those are going to be my asymptotes. So right off the bat, let me say my asymptotes are going to be y equals plus or minus, again, rise over run. So my y is 2, my run is 3. So 2/3 x. Those are my asymptotes. Okay. Now, my foci. Remember that c squared equals a squared plus b squared. Well, this is 4 plus 9, or 13. So c equals root 13. So my foci, remember your foci are always on your transverse axis, are going to be 0 plus or minus root 13. Now, root 13 is about 3.6. Okay, let me just say that so it'll be a little easier to graph. So 3.6, kind of like in here. Okay. Now, let's actually draw the two branches of the hyperbola then. We start at the vertex and we just draw out, hugging the asymptotes. Okay. Not the best drawing in the world because my asymptote lines are not very straight, but you get the idea. Okay. All right, hope that helped. Let's go down to the next one. So next problem is x squared over 49 minus y squared over 36 equals 1. Okay, once again, right off the bat, this tells me that it is horizontal axis because we started with an x squared. Okay, x squared is like your run. Obviously, your x-axis is horizontal. So because the x squared is in front, I know my transverse axis is horizontal. Okay, now this 49 is a squared, so that means a equals 7. Okay, so I'm going to go ahead and graph that. 1, 2, 3, 4, 5, 6, 7. -7. Okay, those are my two vertices. Now, this is my b squared, so that means b is 6. Okay, again, don't really need that other than my box. Okay. So if I draw my box, it's going to look something like this. Okay. I'm having a serious delay on the writing on the smartboard. Okay, so here's my asymptotes. Okay. Maybe if I just draw half, I can keep them straighter. Okay, those are my asymptotes. Okay, so I can go ahead and say My asymptotes are y equals plus or minus. Now again, asymptotes rise over run. My rise was 6, my run was 7, right? So 6/7 x. That's my asymptote. Okay, I can also go ahead, I graphed my vertices, but I didn't label them. This would be plus or minus 7, 0. Again, it's horizontal. Sorry, I thought I saw something up above. Okay, foci. Now, next thing I need. So remember your formula. C squared equals A squared plus B squared. So for us, that is 49 plus 36, which is 85. So C equals square root of 85. Okay, now as a decimal, let me see, that is about 9.2. Okay. So my foci are plus or minus root 85. That doesn't reduce, I don't think, comma 0. And again, that's about 9.2. So on my graph, that would be like right here, right here. Now, if I graph my hyperbola then, again, I am hugging, this is a really fat one, I am hugging my asymptote lines, okay? All right, hope you guys can see that. Hope that's all right. Next one. Okay, I have x squared minus 4y squared equals 16. Okay, now, on this one, obviously it's not in standard form of a hyperbola. So in order to get standard form of a hyperbola, our constant on the right side of the equation has to be a 1. So the first thing I'm going to do is come through here and divide the whole thing by 16. Okay, that's going to give me a new equation of x squared over 16 minus y squared over 4 equals 1. Okay, hope you all can see that. Now, once again, because my x is in the front, this is going to be another horizontal transverse axis. Okay, so this is a squared, so that means a is 4. So that means my vertices are plus or minus 4, 0. So 1, 2, 3, 4. 1, 2, 3, 4. Here's my vertices. Okay. Now, the 4 here is my b squared, so that means b is 2. Now, that means up 2, down 2. So again, this would be my box. Okay. Now, again, all my box is really good for is my asymptotes. Okay, these are going to be much skinnier branches of my hyperbola because my slope is a lot less. So let's go ahead and do asymptote then. My asymptote is going to be y equals plus or minus, again, rise over run. So that's 2 over 4, right? Which, of course, gives me 1/2 x. Okay. Now, I've got vertices, I've got asymptotes, let's do foci. Remember, on my foci, okay, c squared equals a squared plus b squared. Well, that is 16 plus 4, which is 20. So that means c equals square root of 20, which is 2 root 5, which as a decimal is approximately 4.5. I think it's like 4.47 or something, but 4.5. Okay. Now, so my foci, remember, are on your transverse axis. So since that's horizontal, this is plus or minus 2 root 5, comma 0. That would be my foci coordinates. Okay. And let's go ahead and graph those. So about 4.5, since these are 4, it's going to be right. The skinnier, the closer it is to your vertex, the skinnier the hyperbola branches. So now drawing these, again, these are much skinnier because they are using the asymptotes there as their guides, and that has a much less steep slope. I don't know if that was very good grammar, but I think you guys get the idea. Okay, so again, if you start with x squared, your transverse axis is horizontal. If you start with y squared, like we did the first one, let me scroll up, your transverse axis is vertical. Okay, and then your branches are pointing up and down, up and down. Okay, if you start with x squared, your branches are pointing left and right. Okay, let's move on. Backside of your study guide. Now, if they give us a graph or they give us some important pieces, can we come up with the equation? Absolutely. Okay. We need vertices, and asymptotes are good, or foci, and then we can find the b. So here they gave us foci. Okay. Remember, that is going to give us our c, right? And they gave us vertices, which are going to give us our a. Okay, so then if this is our basic formula for c squared, then that tells us we can rearrange it and say that b squared equals c squared minus a squared. So then we can find b squared. And then all we have to have is a squared and b squared. And we have to know which one comes first, the x or y, in order to write the equation. That's all we need. Okay, this one, because the hyperbola pointed up and down, we knew the transverse axis had to be vertical, so we knew the y squared had to be in the front. Again, transverse axis is vertical, so y squared had to be in the front. Okay. This hyperbolic mirror, I'm not going to do that one. It's kind of crazy. Takes quite a bit of effort. You can look through the example 3 here. However, they do a whole lot of skipping to get from here to there. And I don't like that they just magically say, oh yeah, voila, if you solve that, you get 9. Well, how do they solve that? And I did it myself, and if I had a ton of time, I could show you, but it is a little labor intensive. It's not hard, just labor intensive. We're going to skip that. We're going to do 4 and 5. So write an equation of the hyperbola with the given characteristics and center at 0, 0. So first thing that jumps out at me, they give me a foci, that's my C. They give me a vertice, okay, that's my A. Now, this vertice, because it's 0, whatever, this is going to be vertical. Okay, I know it's got to be vertical. If my vertice is on the y-axis, a 0 plus 3 or 0 minus 3 is on the y-axis, that tells me my transverse axis is vertical. So the only other thing I need to find out now is b squared. So first of all, remember that c squared equals a squared plus b squared. So that means that b squared equals c squared minus a squared. Okay, so b squared is going to be c squared. If we square square root of 13, we get 13 minus 9, which is 4. Okay, so that's really all I need to know. So this one, my equation, because it's vertical, I know the y squared has to be in the front. So y squared over a squared, that's 9, minus x squared over b squared, that's 4, equals 1. That should be it. So these are actually, I think, pretty easy. You just, again, you have to know the a squared, you have to find your b squared, and then you have to know which one goes in front, whether it's a vertical transverse axis or horizontal transverse axis. Okay, next one. Again, this is my C, this is my A, okay? And because this is on the x-axis, I know this one is horizontal. So I know when I go to write this sucker that the x squared is going to go in the front, okay? So let's find our b squared. Remember, b squared equals c squared minus a squared. So c squared is just going to be 20 minus a squared is 4. Okay, so that's going to give me 16. So my equation, okay, again, it's horizontal, so I have to start with x squared. X squared over 4 minus y squared over 16 equals 1. Okay, I hope that's helpful. All right, and again, I'm skipping number 6 simply because it's a crap ton of work. Okay, let's look at some problems on practice A. Okay, match the equation with its graph. I'm not going to do any of these. Remember that if it starts with x squared, the transverse axis is horizontal. If it starts with y squared, the transverse axis is vertical. Right off the bat, that should give you the answer to one of them. Okay, then all you have to do is figure out what your A is on the other ones to figure out how far over your vertices are. Okay, moving right along. Graph the equation, identify the vertices, foci, and asymptotes of the parabola. I did lots, well, I shouldn't say lots, did 3 of these in the study guide. So I'm going to kind of quickly blow through here, okay? First thing that jumps out at me is that this has got to be horizontal, okay? My transverse axis is horizontal because it starts with x squared, okay? So that's also going to tell me then if a squared is 1, a is 1. So my vertices are going to be plus or minus 1, comma 0. Right here and right here are my 2 vertices. Okay? Now, this is my b squared. So that means that b is 2. Now again, all I really need that for is to draw the asymptote box. That's kind of what I call it. I know it's going to go 2 up and 2 down. So here's my asymptote box. Okay? Now, my foci. Okay? Remember, c squared equals a squared plus b squared. So for us, c squared equals 1 plus 4, which is 5. So that means c is root 5. Okay? Root 5 is approximately 2.24, like 2 1/4. Okay? So, well, first of all, let me say my focus then, or my foci, are going to be plus or minus root 5, comma 0. Okay, remember your foci are always on your transverse axis. So 2 1/4, 2 1/4. These are my foci. Okay, My asymptotes, I should have gone ahead and done those. Asymptotes, remember, are y equals plus or minus your rise over your run. Well, your b is 2, your a is 1. Your b is under your y, so that's why I put it on top. That's my rise. So plus or minus 2x. Okay? And then all we have left to do is graph. And again, these are going to be fat ones. Again, the fatter the branches of your hyperbola, the farther out the foci are from the vertex. Just kind of a general rule. Okay, let me quickly do number 6 again with you. So this one thing that jumps out at me, we start with y squared. So this is going to be vertical axis. Okay, this is telling me my a is 5. This is telling me my b is going to be 6. Okay, so first of all, my vertices, okay, are going to be 0, comma, plus or minus 5. Remember, it's vertical. Okay, so I'm going up 5. Remember, we're counting by 3s. I hate when they do that. And down 5. Okay, so that's my vertices. Okay, now let me go ahead and do my asymptotes then. Remember, left and right 6 are going to be my asymptotes. So this is going to be my asymptote box. Okay, so here's my asymptotes. All right, asymptotes are going to be y equals plus or minus. Remember, it is rise over run. So it's, in this case, what's under your y, a is 5, over your run, what's under your x is going to be 6. So plus or minus 5/6 x. Those are my asymptotes. Okay. Now, my foci. Foci, remember, c squared equals a squared plus b squared on these, which is 25 plus 36, okay, which is 61. So c equals square root of 61. Now, as a decimal, that's about 7.8. I don't know if you can even see that. But let's go ahead and label my foci here. It's going to be 0 plus or minus square root 61. Okay, but if we go to plot it, okay, it's 7.8. So I don't know, somewhere around in there. Remember, we're counting by 3s. Okay, and then graph the branches of your hyperbola. Again, they hug the asymptotes. Okay. This one again is vertical because it started with y squared. Okay. Let's go down here. Let's do number 11. Write an equation of the hyperbola with the given foci and vertices. Okay, our foci, remember, gives us our c. Okay. Our vertices gives us our a. Okay, so remember, b squared, well, let me start with c squared equals a squared plus b squared. So that means b squared equals c squared minus a squared. Okay, so b squared equals 25 minus 9, which is 16. Now, the only other thing we need, so we've got b squared is 16, we've got a squared is 9. This, because it's on 0, 3 and 0, -3, because it's on the y-axis, this is going to have a vertical transverse axis. So that means my equation is going to start with y squared over 9 minus x squared over 16 equals 1. Okay? Y squared over 9 minus x squared over 16 equals 1. Again, got to start with the y squared since we had a vertical transverse axis. 12, I'm actually going to cross through because I don't think the answer key is correct. And I've read through this a couple of different times, and I don't really like the way it's worded. So it's kind of confusing. I'm not even going to bother. Okay. So here we go. This concludes 8.5, which was all about hyperbolas.